Hello class, in this lesson we're going to be looking at the graphs of sine functions. The learning intention of this lesson is for us to learn how to graph sine functions that has vertical translations. Before you sketch any trigonometric functions, whether it's a sine function, cosine function, or a tan function, it's really important that you find as many of the following features listed down below. It's really critical that you find out what is your amplitude, your period, your x-intercept, y-intercept, minimum, as well as your maximum, okay? And if you find all of these features, then your graph will be absolutely accurate when you actually draw it. Whenever you encounter questions that do ask you to graph a trigonometric functions, most of the questions will require you to actually draw one cycle. So in the image that I have down below, this is an example of a sine function, but in this particular image, they've actually shown multiple cycles, okay? And you really only need to show one cycle. So for instance, a sine function over here starts from here to here. So that's this part over here, this length is one cycle or one period, and another period is also shown over here as well. So they've drawn two cycles. You really only need to show one cycle, so you could only just show, for instance, this portion of the graph only. In order for us to graph a trigonometric functions, you could actually do this using two methods. The first method is graphing the trigonometric functions conceptually. And in order to do it using this particular process, you need to understand what is the basic shape of the parent function. So knowing what y is equal to sine x looks like and knowing what y is equal to cos x looks like. And then using your understanding of transformations, you could therefore graph the correct equation, okay? So if there is a dilation, then you would stretch it. And if there is a vertical translation, you would just move the graph up or down. Another way of doing this is actually using a procedural method. So that's a more algebraic approach. And in this particular method over here, you are required to find out what are the x-intercepts and the y-intercepts for you to accurately sketch the trigonometric function. For the purposes of this subject over here, we're going to learn how to graph the trigonometric functions conceptually. But when you guys do pick up maths methods and specialist maths in VCE, you will learn how to actually solve this algebraically. And this is actually a lot more harder because there are several lines of calculations that you need to do in order to get the answer. So let's learn how to actually graph the sine function that has dilations and reflections in it. Remember that when we were looking at transformations in the previous video, by changing the value of a, this is an example of dilation, and essentially you're going to be changing the amplitude, which is the distance from the midline, the middle of the graph, to a peak, okay? Whenever you have a large a value, what happens is that you're going to be stretching the graph. As a result, you will have a large peak. In contrast, a small a value will result in smaller peaks, so the graph will therefore appear more smaller. When we're reflecting the graph, that's when you have a negative a value in front of the equation. So this flips the graph over the x-axis. So let's look at one example together so that you have a better understanding of how to graph sine functions with a dilation. So this is y is equal to 3 sine x, and you're also required to state what the period and amplitude is. Because I am only going to be sketching one cycle, this is the reason why I provided this grid template over here, and you're going to be graphing your circular functions, your trigonometric functions, in a very similar manner as well. Now, we know that for the parent function, okay, the period is normally 2 pi. And normally when you're drawing it, a trig function, you should kind of divide your graph into like 4 sections that I've done over here. That's 2 pi, so therefore the center is going to be pi. To find out what this is, that's essentially half a pi, so that's going to be pi on 2. And because this pretty much goes by pi on 2, pi plus pi on 2 will give you this value, which is 3 pi on 2. But you would know that that's 360, that's 180, therefore that's 90, therefore that's going to be 270, right? In degrees mode. But remember that we often use radians as opposed to degrees when we're looking at this particular topic. So if I'm trying to find the amplitude, that's going to be the value of a. The value of a in this case is a number in front of the sine, so that's 3. To find the period, remember the formula was 2 pi divided by b, where b is a coefficient in front of x. In this example, your coefficient is 1, so 2 pi divided by 1 is still going to give you 2 pi. So that's going to be your period in this case over here. To find the minimum value, in this case, because you don't have any vertical translations, your minimum value is going to be the negative value of a, and your maximum value is going to be the positive value of a, right? So what I'm going to show you first is how do you actually graph y is equal to sine x, And based off this, then I'll show you how I would actually graph this bad boy over here. So remember, guys, to graph y is equal to sine x, you can kind of get this information from your unit circle over here. We know that sine, remember, represents the y values. Okay, so sine represents the y values. So when y is equal to 0 degrees, 0 is over here, your y value in this case is 0, so therefore your dot is going to be here. When it's pi on 2, which means when it's 90 degrees, okay, so if you move 90 degrees this way, what is your y value of here? Your y value is equal to 1 because that's the radius of the unit circle. So therefore, I'll be plotting a dot over here. At pi, which is 180, your y value is 0. At 3 pi on 2, that's going to be -1, as you can see here. And as you move back over here to the starting point, that's also going to be 0. So therefore, for the most basic parent function y is equal to sine x, this is what the graph would look like, okay? But remember, we're going to draw what this is going to be. And one of the ways that you could draw this is by obviously extending the arms of this and therefore going up to 3 and then graphing it. Because remember, this affects the peak, so the distance between the midline to the peak. So therefore, you could draw a dot over here, but I suppose a more easier way of doing this is changing this value here. So instead of going 1 and -1, just change this to the values 3 and -3, because that, remember, is going to be your minimum and your maximum. You're not really vertically translating at all, so you can kind of use this method to quickly get the answer. Let's look at another example. So in this particular example over here, you also have a dilation as well as a reflection. So your amplitude in this case over here, remember, is always going to be the positive value. So it's going to be equal to 4 because distance cannot be a negative value. Your period in this case over here is going to be the exact same thing because you don't have a coefficient in front of x. Your minimum value is going to be -4 and your maximum value is going to be +4. So in this example over here, I'm going to draw the most basic sine function, and then based off that, I'll use my understanding of transformations to get me the final answer. So in this case over here, again, sine, what is the y value when it's at 0 degrees? That's going to be 0. At pi on 2, that's going to be over here, 1 and so forth. So you should be able to get these ones quite readily. But because this has a negative sign over here, that would imply that I would need to flip the graph. So I'm changing, as you can see over here, I've changed this down to the other side below the x-axis, and I've also changed this above the x-axis. Obviously, these points over here, because they're on the x-axis, if you flip them, they're still going to be at the same location. So therefore, this graph over here is going to be y is equal to negative sine x, but we need to graph y is equal to -4 sine x. So that, remember, changes the height of the peak. So a quick way of doing that is just changing these values over here. So change that to +4 and -4, and therefore this is how you would graph y is equal to -4 sine x. All right, have a go with answering this question over here. Give yourself 2 minutes and then we'll compare our answers together. So if you guys have done this successfully, the correct answer over here should be D. The reason why it's going to be D is because this negative sign indicates that you're reflecting. So instead of having this graph over here, it should therefore be like this. And this 5 over here changes the amplitude. So therefore, the minimum value should be -5 and your maximum value is going to be +5. And that's the reason why D is going to be the correct answer. B and C, it can't be the correct answer because that's a cos graph. And for this particular graph over here, that's incorrect because they haven't reflected the graph over. We're now going to be looking at how do you actually graph sine functions where the period is not 2 pi. So we know that for the parent function, the graph of sine x is going to equal to 2 pi, right? And we can prove that as well. So in this case, the coefficient in front of sine x is 1, so therefore the period is equal to 2 pi. But when you've got a coefficient other than 1, this ultimately changes the frequency, and adjusting the frequency changes the horizontal distance to complete one full cycle. So by calculating this over here, 2 pi divided by 2, that will give you pi over here. So therefore, because this number is smaller than this number, this makes the distance to complete one cycle a lot more shorter. So in this case, your period to graph sine 2x, which is represented by the blue graph, is a lot shorter, as you can see over here. It's basically half of the first one. So just to remember, guys, whenever you see a large b value in front, this will have a smaller period, also a smaller horizontal distance, whereas a small b value will result in a larger period, which in this case means a larger horizontal distance. Let's now look at an example of how you could actually graph a trig function that has a different period, okay? And I'm going to show you two ways of doing this. So in this case over here, I'm going to follow the exact same process. So in this case, I'm going to find out what is my amplitude. My amplitude over here is going to be 2 because that's the value of A. Your period is found by 2b divided by b. In this case, your b value is equal to 2. So by substituting 2 over here, our period is going to equal to pi. So therefore, to complete one cycle, that's going to be done over here to pi units. So therefore, it's going to be a lot more shorter. So we don't really require this whole entire space over here, right? Your minimum value is going to be -2 and your maximum value is going to equal to +2, all right? So let's first start off by drawing what is the regular function. So in this case, what I'm going to show you is how would I draw y is equal to 2 sine x, okay? So I'm going to just draw the regular version where it doesn't have this 2 over here. So therefore, because I don't have a 2 there, I'm going to take the whole space. My full cycle will go all the way to 2 pi. And the reason why I'm doing this is because I'm going to keep this the same. So therefore, your amplitude is going to go up to 2. So therefore, if I was just to keep this the same, therefore your graph would still look something similar to this for y is equal to 2 sine x. But in this case, the only difference between these two equations over here was that the period for this bad boy goes to 2 pi, whereas the period of this is pi. Now we know that the difference or the ratio between 2 pi and pi is a half. So therefore, in order for you to graph what this guy is, all you simply need to do is simply halve all the x coordinates to get the actual graph itself, okay? Because the reason why we're doing that is because remember, period means horizontal distance, and therefore by changing this whole distance to pi, you need to therefore adjust these coordinates over here accordingly as well. So therefore, if I was to change this guy over here, this will remain the same because 0 divided by 2 is still 0. This coordinate over here, instead of going pi on 2, if I half that, this position would now be over here. This position over here will now be over here, pi on 2, because half of pi is pi on 2. If I half this position, that's going to lie over here, and half of 2 pi is equal to pi. And as you can see, the distance for it to complete is now pi, right? So that's one way of doing this. And as you can see over here, to graph something that has a smaller period, it doesn't require the whole space that we've allocated for, right? So I want to show you another way of doing this. So another way of doing this is pretty much changing the scale along your x-axis. Because we know it doesn't take up the whole space, let's change it. We know for a full cycle, it goes up to pi. So instead of going 2 pi, let's half every single x value here. Half of 2 pi is equal to pi, and as you can see, I've changed that. Half of pi, which is over here now, is going to be pi on 2, and therefore we just change these by dividing it by 2, and therefore this is what it will look like. Hence, your graph would look like this, and that's probably an easier way of doing this, okay? So have a go and see whether you can get the correct answer. Give yourself 2 minutes and then we'll compare our answers together. If you guys have answered this correctly, the correct answer over here is going to be C. So in this case over here, the reason why it's C is because if you go 2 pi divided by b and substitute 1/2 in, you should get your period as equal to 4 pi. So your answers can either be option C or option D. It can't be these two options because your period is only 2 pi, okay? Now, in this case over here, your amplitude should be 4. So therefore, this is going to be the correct answer because your minimum and maximum value is equal to -4 and +4. It shouldn't be half or -half at all. We are now moving to the last part of the lesson where we're going to be graphing sine functions with vertical shifts or vertical translations. So whenever you've got a vertical translation, that's just essentially when your d value is not equal to 0. So if you've got a positive d value, that means you're shifting the graph upwards, as you can see over here by the green graph. But when you've got a d value that's negative, right? Then therefore you're going to be moving the graph downwards. And as you can see here, this -3 moved the graph 3 units down. So in order for you to graph it, all you really need to do is just sketch what the graph would look like without the vertical translation. And then after you do that, you just need to shift the coordinates up or down depending on what the d value is in the equation. And because you are sketching what the graph would look like without the vertical translation as step number 1, I highly recommend you use pencils to sketch what this looks like and then erase it afterwards once you've done the final graph. So in this case, let's just say hypothetically, I was trying to graph what does y is equal to sine x plus 3 looks like, okay? So in this case, this would imply that I need to move 3 units up. So therefore, these are the coordinates I do know. So I just need to move each of these coordinates 3 units up, and therefore just connect the lines together, and therefore this is what your graph would look like. So that's pretty much the basis of how you would graph sine functions with vertical shifts. So let's look at an example together. The example reads, sketch one cycle for the function y is equal to 1 minus 2 sine 2x. Now, when it's rewritten like in this particular form, they generally try to confuse you guys. This is the same thing as writing y is equal to negative 2 sine 2x plus 1. Okay, so in this case over here, your translation is 1 unit up. And in this case, you are having a reflection and your amplitude is going to be 2. So do the same thing. Amplitude of here is going to be equal to 2. To find out the period is going to be 2 pi on b. Your b value is 2, so therefore your period is going to be equal to pi. Your minimum value is going to be different in the way that you calculate it. It's going to be, remember, negative a plus d. So that's how I got negative 2. Plus 1, and therefore that's going to give me equal to negative 1. Your maximum value is found by going positive a plus d, so therefore 2 plus 1 is equal to 3. So that's the highest y value. Now that you found this out, we could therefore graph it. In this case, because I know that a full cycle goes up to pi, therefore I'm making this part over here equal to pi. Now that I've got that, I'm going to sketch what does y is equal to negative 2 sine 2x looks like, and then once I've done that, I could therefore move it 1 unit up. So therefore, because it's negative, I know that it's going to be reflecting over the x-axis. So therefore, if I was plotting this, my graph of y is equal to negative 2 sine 2x is going to look something similar to this over here, right? And I know that this is going to be correct because, as you can see, the amplitude is 2 and it's reflected as well. Now that I've done that, I've just shifted the coordinates 1 unit up to graph what this guy over here is. Okay, so just to show you again, I've now shifted it up. So now in order to graph this, all I need to do now is just connect the dots, and therefore this is going to be what the graph would look like for y is equal to 1 minus 2 sine 2x. Now that we've gone through an example together, have a go with answering this question up here. Give yourself 2 minutes and then we'll compare the answers together. So if you guys have answered this correctly, the correct answer is going to be A. Now, if you're probably wondering why is this 2 pi and 3, if you calculate the period, 2 pi divided by b, that's equal to 3. So that's why I put 2 pi and 3 over here. The reason why the other answers are wrong is because if we look at this option over here, your amplitude is equal to 1, but we can see the amplitude is 3, so that's why we've eliminated option B. We could eliminate option C is because that this over here is an example of a reflected sine function, so you could eliminate that option. And for option D over here, this is when they've translated 2 units up, because you can see your midline's over here, so that would imply you've shifted up as opposed to shifting down, so option D is incorrect. Now that we've gone through all of the content, I would like you to please answer these questions over here. So refer to the questions that I'm actually showing to you right now. There's also questions C and D, but those had horizontal translation, so don't worry about them for now. I also want you to ignore these questions over here. Don't do questions B and D, and don't do C and D for questions 3, because these over here have horizontal translations and we haven't covered those examples over here. Hopefully you should be able to meet the success criteria by the end of this video. Thank you for watching, and I'll see you guys again in the next video. Bye.